Hello friends, I am going to discuss illustration number 5 of risk uncertainty CMA final SFM. Okay, please let us start the questions here. Please, please read the questions. Illustration number 5. A cyber company is considering two mutually exclusive projects. Investment in the output of the both the projects rupees 5 lakh. There are two projects, project A and project B. Both the project has the same investment, that is the present value of cash outflow rupees 5 lakh. This is rupees 5 lakh investment. Okay, and the probability distribution is given for the good, normal and worse. 6 lakh cash inflow for project A having probability 0.3, 4 lakh cash inflow for A in normal case, probability of this is 0.4, and 2 lakh cash inflow for worst case 0.3 probability. And similarly for B is 5 lakh, 4 lakh and 3 lakhs. Cost of capital is 9%. Which project should be accepted? Explain with the working. Which project should be accepted? In this case, we are going to calculate net present value and a standard deviation for project A and project B. Okay. Calculation of net present value and a standard deviation for project A. For project A. Net present value and a standard deviation for project A. Look at it. In this case, you write the situation. Cash inflow. This is your probability. Cash flow is assumed to X. Probability. This is PI. This is the PI XI. PI XI. This is a PI XI X square. In this case, there are three situations: good, normal, worse. Good, normal, worse. Cash inflow for project A 6 lakh, 4 lakh, 2 lakh. 6 lakh, 4 lakh, 2 lakh. And probability of this is 0.3, 0.4, 0.3. 0.3, 0.4, 0.3. This is the cash inflow. Okay, look at it. Now PIXI 6 multiplied to the 0.3, 1.8 lakh. 4 multiplied to this 1.6 lakh. 2 multiplied to 0.6, 0.6 lakh. This. Then PIXI is a 4. PIXI is a 4 lakh. Now PIXI square 1.8 into 6, 1.8 into 6, this is a 10.8 lakh. 1.6 into 4, 6.4 lakh. 0.6 into 2, 1.2 lakh. This is a 18.4. Now what will be the expected cash inflow? Expected cash inflow is summation PIXI is rupees 4 lakh. A standard deviation. Formula is root under summation PIXI x square expected x whole x square. This is 18.4 minus 4x square, that is 18.4 minus 6, this is 2.4, 1.54919 lakh, 54919 lakh. This is a net present. Now we have to calculate net present value. Net present value equal to present value of cash inflow minus present value of cash outflow. Inflow is considered to be expected cash inflow. Wherever there are several opportunities of cash inflow, in the case of probability distribution, in that case we need to calculate expected cash inflow, and that cash inflow is assumed as a cash inflow of the project. This is because of average cash inflow. This is a 4 into present value annuity factor. This is a 9% and 5 year, because of the project life is a 5 year. It is a written here. Project life is a 5 year. This is written here. Okay, that's why. Minus outflow is a 5 lakh. Outflow is a 5 lakh. Here, what can you write? 4 into 3.89 minus 5 lakh. 4 into 3.89 into 5 lakh. This is 15.56. This is 15.56 minus 5. 10.56 lakh. 10.56 lakh. Now, in this case, your net present value is this and a standard deviation is this. Okay. Now, exactly we have to do the same for project B. Okay. Look at here. Calculation of net present value and a standard deviation for project B. Net present value and a standard deviation for project B. Okay. Here you write situation. There are three situations. One is a good, normal, that is the worse. Good, normal and worse. Okay. Now, cash inflow. This is assumed as a xi. Probability. This is assumed as a pi. You have to calculate pi xi and pi xi x square. This is x square of only xi. The cash inflow for this is, look at here. For B project is 5 lakh, 4 lakh, 3 lakh. This is the 5 lakh, 4 lakh and 3 lakh. And probability is 0.30, 0.40, 0.30. 1.5 lakh, 1.6 lakh or 0.90 lakh. The sum of this is the 4 lakh. It means the expected cash inflow for project B is also 4 lakh. Now 1.5 lakh is multiplied with 5. This is a 7.5 lakh. 1.6 multiplied with 4. This is a 6.4 lakh. 6.4 lakh. 3 into multiplied with the 2.7 lakh. Now this is 16.6 lakh. Expected cash inflow. This is summation pi xi. This is the 4 lakh. A standard deviation is represented like this. summation pi xi x square minus expected x whole x square. This is 16.6 minus 4 lakh. This is 16.6 lakh. This is just 16 lakh. This is 0.6 lakh. This is 1.0.774596 lakh. Net present value, we have to calculate net present value of cash inflow minus present value of cash outflow. Net present value will be the same because of the same expected cash inflow and same outflow. Okay, 4 into present value annuity factor 9% 5 year minus outflow is 5 lakh. 4 into 3.89 minus 5 lakh. This is the same 15.56 minus 5 10.56 lakh. Okay. Decision is taken on the basis of net present value. Both the project has the same net present value 10.56 lakh. Hence, both the project on the basis of net present value is equally likely. Okay, but a standard deviation of project B is lower than project A. That's why project B is selected. Now, how will you give the decision here? Please look at here the decision. Please. Here you write project. Here A and B. Net present value of both the project is same 10.56 lakh. 10.56 lakh. A standard deviation for project A is 1.56 54919 lakh. 919 lakh. 0.777 4596. 4596. Look at it. Here both projects A and B are equally likely on the basis of net present value having same net present value 10.56 lakh, but a standard deviation of project B is lower than project A. Hence, risk of project B is lower than project A. Risk of project A is lower, B is lower than project A. Therefore, project B is selected. Project B is selected because having same net present value at lower risk. Same net present value at lower risk. Okay, this question is completed. A part is completed right now. Now I am going to solve the question number B part 5B. Look at it. A company is considering the project X and Y with the following information. This expected net present value for X is this and this. A standard deviation of this and this. Which project will you recommend based on the above data? We have to based on the above data. So on the basis of net present value, we can select project Y because of having high net present value. And on the basis of a standard deviation, we project X because of low standard deviation, low risk. Therefore, this is conflict of ranking on the basis of net present value and standard deviations. In this case, we need to calculate coefficient of variance, and project having lower coefficient of variance should be selected. Okay, explain whether your opinion will be changed if you use the coefficient of variance as the measure of risk. Yes, it may be. We need to calculate coefficient of variance. Which measure is more appropriate in the situation and why? That is net present value is a more better because of net present value is directly proportional to wealth of the equity shareholders. Okay, okay, I'm going to solve the questions. Okay, answer B part. 5B answer. Okay, look at here. Project X and Y. Look at it. Net present value. This is assumed to be X bar. Net present value. This is given. Net present value, that is project X, is 1,06,000 this, and 2,40,000 is this. 2,40,000, and thereafter your standard deviation, that this is 75,000, 1,35,000. We need to calculate coefficient of variance. Coefficient of variance. This is standard deviation divided by this is the coefficient of variance. In this case, a standard deviation is just 75,000, and this is 1,06,000, 1,35,000. This is 2,40,000. In this case, what will be the standard deviation? You have 0.71, and this is 0.5626. Okay, the first part answer is answer of first part. What is the question you have? Which project you will recommend based on the above data? In this case, which project will you recommend? Look at here. If decision is based on net present value, then project Y is selected having high net present value, and if decision is based on a standard deviation, then project X is selected having low standard deviation or low risk. This is conflict of ranking. Conflict of ranking. Okay. And now in the second case, what is asking? Explain whether your opinion will change if you use coefficient of variance measure, coefficient of variation measure of risk. Look at here. In this case also, if there is a conflict of ranking, then decision is based taken on the basis of net present value. Okay, decision is taken on the basis of net present value, and coefficient of variance in this case, whenever there is conflict of ranking, then decision is taken on the basis of investor perspective. What investor wants, whether investor wants a high risk and high return, or investor want low risk low return, that depends. In the second case, answer, in which favor your decision will be, the project having low standard deviation should be selected. The project Y is selected having low coefficient of correlation, low coefficient of variance, low coefficient of variance. In third part, you have also the same questions is asking here. Which measure is more appropriate in the situation and why? Out of these two measures, which measure is more appropriate? Net present value is more appropriate for selecting projects because it is directly proportional to wealth of the equity shareholder. Wealth of the equity shareholder. Directly proportional to wealth of the equity shareholder. So in this way, we have completed these questions. Okay. Thank you, class. Please like, subscribe, and share my videos.